Good morning, everyone. Uh, welcome to today. Welcome to session two. Sorry, part two of atoms. Previous year questions. So, as you know, in the first part of atoms previous year questions, we covered around 17 questions, and today I will be discussing you with. I will be discussing rest of the 16 or 17 questions for today for today's session. Okay. So mostly most of the theoretical part and most of the formula which are related to this chapter, I have already told you in the session one. So this is only going to be the application of those formulas mostly. Okay. And here we have some of mostly here we'll cover theoretical questions. Okay. So I'm Sumit Nahak. I had secured All India rank 691 in NEET, and here I am as your physics tutor. Okay, so let's begin. So yesterday we discussed around 17 questions till here. This was our last question yesterday. So today I will be continuing with the part two, question number 18. So question number 18 says J.J. Thomson's experiment demonstrated that J.J. Thomson's, if you don't know what was J.J. Thomson's experiment, first I'll explain what is J.J. Thomson's experiment. What did J.J. Thomson do? J.J. Thomson observed that if you know what is a cake pudding model of electron, cake pudding model of electron, J.J. Thomson told that the structure of atom is like a cake. The structure of atom is like a cake where the electrons are like a pudding. Pudding means it is randomly distributed all over the cake. It is randomly distributed like this. This is what was J.J. Thomson's experiment. This was the result of the J.J. Thomson's experiment. Okay. So in this experiment, he demonstrated which of the following is correct. We have to see. Okay. What was his experiment actually? He took a cathode tube. He took a cathode tube and connected to a circuit. Connected to a circuit, and in that cathode tube, he emitted cathode rays. He emitted cathode rays. Okay. This was his experiment. So in this experiment, what did he do? We have to select the correct option among these four. So option A says the electron mass ratio of the cathode ray particles changes when a different gas is placed in a discharge tube. The EM ratio, the EM electron upon mass of the electron ratio changes when it is placed in other discharge tube. No, electron mass ratio will always be same irrespective of the cathode tube you are putting the cathode rays in. Why? Because the mass of the electron, the charge of the electron and the mass of the electron of all the electrons in every atom is same. For example, if you're taking a nitrogen atom or if you're taking an oxygen atom, okay? In nitrogen atom, if you're taking an electron from nitrogen atom and you're taking another electron from oxygen atom, yeah? So the charge of both the electrons will be same here, and the mass of both the electrons will also be same here. Okay, so the EM ratio will be same in all of the atoms. Okay, this you have to make it clear in your mind. So this option A is wrong. He did not demonstrate this. He told EM ratio, electron upon mass ratio, will always be same in all the atoms. Option B says cathode rays are stream of negatively charged ions. Yeah, cathode rays were negatively charged ions. These were negatively charged ions. So option B is option B is correct. Then option C says all the mass of an atom is essentially in the nucleus. No, This was given by Rutherford. Rutherford told all the mass of the atom is concentrated in a small space that is called as nucleus. But J.J. Thomson told all the mass of the atom is not concentrated in the nucleus. It is evenly distributed. He told cake pudding model. That is evenly distributed mass. He told evenly distributed. Okay. So it is Rutherford, not J.J. Thomson. So option C is wrong. Then option D says the charge upon mass ratio of electrons is much greater than charge upon mass ratio of protons. Will it be like that? See, charge of both electron and proton are same because electron also carries one negative charge, proton also carries one positive charge. Though sign is different, but the value is same. Electron and proton charge is same. They both carry the same charge. But what they're asking you, EM ratio. Which will have a higher EM ratio? Mass of electron is more or mass of proton is more? I think everyone knows this. Mass of proton is very, very, very higher than the mass of electron. So the ratio of EM in an electron will be more than ratio of EM in a proton. Why? Because mass of electron is in denominator. Since the mass of electron is very less, this whole ratio will be high. I hope it's very clear. So option D is also wrong because they are saying uh, EM ratio of electrons is much greater than EM ratio of protons. This is correct, but this was given by Rutherford again, not by J.J. Thomson. So J.J. Thomson only told the cathode rays are stream of negatively charged ions. That's it. Yeah. So with this, I'll move to question number 19. Question number 19 says, energy of an hydrogen atom with principal quantum number n is given by E equal to minus 13 point upon n square electron volt. The energy of photon ejected by the electron jumps from n equal to 3 to n equal to 2 state of hydrogen is approximately what? See, whatever the question says, you first draw a diagram. I'm drawing a diagram for hydrogen orbit. This is n equal to 1. This is n equal to 2. This is n equal to 3. This is a hydrogen atom. Okay. The energy of the hydrogen atom is given by the formula minus 13.6 upon n square electron volt. Okay. So what will be the energy when an electron jumps from 3 to 2? 3 to 2, if an electron is jumping from 3 to 2, what will be the energy emitted? What will be the energy emitted? How can you calculate? If you know the energy of the orbit second, if you know the energy of the third orbit, you just need to subtract the energy from the third to second, then you'll get the energy emitted. Obviously, now, if an electron was staying here in third orbit, it will have an energy, and if an electron is moving to second orbit, it will have some energy. So if you subtract the energy of the third orbit with the second orbit, you'll get the energy emitted. So first I'll calculate the energy of the first orbit. What is the energy of the first orbit? Minus 13.6 upon 1 square. What will be the energy of the second orbit? Minus 13.6 upon 2 square. What will be the energy of the third orbit? Minus 13.6 upon 3 square. Okay. So if you divide minus 13.6 upon 4, you will get a value of minus 3.4 electron volt. And the same way, if you divide minus 13.6 upon 9, you'll get a value of minus 1.51 electron volt. Okay. So you have to calculate if I'll write it for you. If an electron is jumping If an electron is jumping from third to second orbit, what will be the energy emitted? Energy emitted will be equal to what? Energy of the third orbit minus energy of the second orbit. So, what is the energy of the third orbit? Minus 1.51 electron volt minus 3.4 electron volt. So, 3.4 minus 1.51. What will be the answer? 1.9 electron volt. So the energy emitted will be 1.9 electron volt, which is our option number A, 1.9 electron volt. Did you understand what it is? This was a very simple question. Yeah. So question number 20 says, in which of the following systems will the radius of the first orbit will be minimum? Radius of first orbit. First orbit mane n equal to 1. Which of the following will have a least radius, minimum radius? Okay. So what do we know? That radius is directly proportional to n square upon z. N square upon z. This you remember. R is directly proportional to the ratio of n square upon z. By this, if you remember this, you can solve a lot of questions from atoms, because most of the questions in atoms will be based on a very few formulae. Okay, and this is one of the most important formula. R is directly proportional to n square upon z. Okay, so which of the following will have minimum radius? We'll calculate. We'll see. Option number A says an hydrogen atom. In hydrogen atom, n will be 1. N is given 1 already. Z is 1. So R is directly proportional to 1 square upon 1. Option number B says ionized lithium, where Z is equal to 3. So R will be proportional to n square upon Z. Then option C says helium singly ionized helium. In singly ionized helium, Z will be equal to 2. So R will be directly proportional to n square upon Z. Value of Z is 2. So R is proportional to 1 upon 2. Option D, deuterium atom. In deuterium atom as well, Z will be equal to 1. So the radius will be proportional to 1 square upon 1. So which of the following is giving you the minimum value here? In hydrogen atom, it is proportional to 1. In doubly ionized lithium, it is proportional to 1 upon 3. Helium, it is proportional to 1 upon 2. Deuterium, again 1. So which one of the following is the minimum value? 1 upon 3, as you all can see. So the answer here will be doubly ionized lithium will have the minimum radius. Option number B. Okay, guys. So with this, I'll move to our next question. Question number 21. Question number 21 says, an electron changes its position from orbit n equal to 2 to orbit n equal to 4 of an atom. So what will be the wavelength of the emitted radiation? So again, for this, I'll draw a diagram. These are the 4 orbits of this. This is hydrogen atom. N equal to 2, n equal to 2, 1, n equal to 2, n equal to 3, and n is equal to 4. So what is happening here? An electron is moving from n equal to 2 to n equal to 4, from here to here. Okay. So what will be the wavelength of the emitted radiation? This is a very easy question if you remember the formula. All of you know the formula 1 upon lambda is equal to R Z square into 1 upon N1 square minus 1 upon N2 square, where R is the Rydberg's constant. R is the Rydberg's constant. So this became easy for you now. How will you calculate the value of lambda? 1 upon lambda is equal to R into 1 upon 2 ka square minus 1 upon 4 ka square will be equal to R into 1 upon 4 minus 1 upon 16. So if you subtract this, if you subtract 1 upon 4 with 1 upon 16, you'll get 1 by lambda is equal to R into 3 upon 16. Okay, so value of lambda will be equal to 16 upon 3R. 16 upon 3R. So in which option you are seeing 16 upon 3R? Option number B. Option number B is the correct answer. Did you understand what happened here? In question number 21, an electron moved from n equal to 2 to n equal to 4. Okay, so you had to find out the value of lambda. Easy, very easy question. You just need to remember this formula. Then you can calculate the answer. Okay, guys. So with this, I'll move to question number 22. Question number 22 says, the energy of an hydrogen atom in nth orbit is En. The energy of an hydrogen atom in nth orbit, energy in nth orbit, energy in nth orbit is En. Okay, which is proportional to, as you all know, energy is proportional, or it is equal to, you can write minus 13.6 Z square upon N square electron volt. I hope you remember this, guys. I am writing the formulas again and again so that it will fit in your mind. Okay. So energy of an electron in nth orbit is equal to minus 13.6 Z square upon N square electron volt. Yeah. So they're asking you what will be the energy in an nth orbit of a singly ionized helium atom. This was for hydrogen. Okay. For hydrogen, they told, for hydrogen, what will be minus 13.6 Z square will be 1 square upon N square electron volt is equal to En. Yeah. This is given in question itself. Now they are asking you what will be the energy of nth orbit in a helium atom. Energy of nth orbit in helium atom. Helium mane Z value is 2. Helium atom. Energy will be equal to minus 13.6 Z square. Z square is 2 ka square is 4 upon N square is 1. N square you can write is nth orbit N square. So this will be equal to 4 into minus 13.6 upon N square electron volt. Okay. So from the equation number 1, you know minus 13.6 upon N square is equal to En. So you can, I am replacing this equation with En. 4 into En, electron volt. So nth orbit, in an nth orbit of helium atom, the value of energy will be equal to 4 En electron volt. In which option it's given? Option number A. Okay, guys. So with this, I'll move to question number 23. Question number 23 says, when an electron jumps from fourth orbit to the second orbit, one gets what? See, draw the diagram. This is n equal to 1. This is n equal to 2. This is n equal to 3. This is n equal to 4. Okay? Electron is jumping from fourth orbit to second orbit. Second orbit. Okay? So, I told you in the last session, if an electron is coming to second orbit from any of the above orbit, third, fourth, fifth, sixth, whatever it may be, if an electron is coming to second orbit, okay, so it will give rise to what series? What series? If it is coming to second means, it will always give rise to Balmer series. It will always give rise to Balmer series. Okay, and if the electron is coming from the third orbit, it will give rise to it will give rise to the first line of Balmer series. If it is coming from fourth orbit, the above orbit, it will give rise to second line of the Balmer series. If it is coming from fifth orbit to second orbit, tell with me, it will give rise to third line of Balmer series. I hope it's very clear for you now. So if an electron is coming from fourth to second, what it will give rise to? Second line of Balmer series. So the answer will be option number C. But guys, see, this is only about Balmer series, but I'll again tell you, if you don't remember of the last session, see, if an electron is coming back to n equal to 1 from any of the orbits, second, third, fourth, to n equal to 1, it will give rise to Lyman series. It will give rise to Lyman series. Okay. Then just now we talked, if n equal to 2, if it is coming from third, fourth, or fifth to from any of the orbit to n equal to 2, it will give rise to Balmer series. It will give rise to Balmer series. And then if it is coming from any of the orbit to n equal to 3, it will give rise to Paschen series. Yeah. And then if n equal to 4, if it is coming from fifth or sixth orbit, it will give rise to bracket series. Bracket series. In the same way, if n is equal to 5, it will give rise to P fund series. You have to remember everything: Lyman, Balmer, Paschen, bracket, P fund, then Humphrey. Till n equal to 6, at least you need to remember. Okay, this is the extra thing I told you. Please remember this, because this may be a future question. So, okay, guys, with this, I'll move to question number 24. Question number 24 says, which of the following transition in an hydrogen atom emits the photon of the highest frequency? Which of the following emits an energy of highest frequency? So, how will you see which one of the following is emitting highest frequency? As you all know, we have a formula: 1 upon lambda is equal to r z square into 1 upon n1 square minus 1 upon n2 square. What is n1 and n2? If the electron is making transition from one orbit to another orbit, that is only n1, n2. Okay, so we know energy is equal to hc upon lambda, and it is also equal to h into nu. Okay, so from this we know nu is proportional to 1 upon lambda. Nu is proportional to 1 upon lambda. So we can write this equation as nu is equal to r, z square is 1 here because it's hydrogen atom, so I'm not mentioning that, r into 1 upon n1 square minus 1 upon n2 square. Okay, so I got a value for nu. So now I have to see which one of the following will have a highest frequency. So we'll check option wise option. Option number A. Option number A has n equal to 2 and n equal to 1. N equal to 2 to n equal to 1. Okay. So the value of nu will be r into 1 upon 1 ka square minus 1 upon 2 ka square. It will be equal to r into 1 minus 1 by 4, which will be equal to 3r by 4. 3r by 4. This is option number A. Okay, keep all the values to compare at the end. Option number B says which one of n equal to 2 to n equal to 6. So nu will be equal to r into 1 upon 6 ka square minus 1 upon 2 ka square. This value will be very less, r into 1 upon 36 minus 1 upon 4. This will be equal to 9r upon 36. 9r upon 36. Then again option C, n equal to 6 to n equal to 2. See guys, the energy difference between n equal to 2 into n equal to 6 is same. So the energy emitted when an electron is moving from second to sixth, or if it is moving from sixth to second, it will be same. Do you understand guys? See, if this is n equal to 2 and this is n equal to 6, okay, so the energy difference will always be same, no matter if the electron is moving from here to here or here to here. Energy difference will be same, and if the energy difference is same, the nu will be same. So I'm not calculating the new value for again this 6 to 2. So this will be again 9r upon 36. Okay, like this you approach to questions in competitive exams, guys. Because if you start solving all the options, it will take you very long time. Okay, so you should be knowing how to tackle all the questions. Okay, how to approach the questions smartly. Then I'll move to option number D. Option number D says n equal to 1 to n equal to 2. Okay, again this will give us a negative value. Nu is equal to r into 1 upon 2 ka square minus 1 upon 1 ka square. This will give us minus 3r upon 4. Which one of the following is maximum? First is 3r by 4, then came nr minus nr upon 36, then it came nr 9r upon 36, then it came again minus 3r upon 4. Which one of the following is maximum? The maximum value is 3r upon 4. So our answer is option number A, 3r upon 4 gives a maximum frequency in the following options given below. So with this, I'll move to question number 25. Question number 25 says, in a Bohr model of hydrogen atom, the centripetal force is furnished by the Coulomb attraction between the proton and electron. Between proton and electron. Okay, so I'll draw a hydrogen atom according to Bohr. This is the hydrogen atom according to Bohr. This is the proton and this is the electron. Okay, so what it is saying, the centripetal force is furnished by the Coulomb attraction between the proton and electron. Proton and electron. So what is happening? If you remember from gravitation or electrostatics, if you remember, in an atom also, all the centripetal force is given by the electrostatic force between proton and electron. Do you understand what I'm saying? The the centripetal force here is equal to electrostatic force. The centripetal force is equal to electrostatic force. And what is the centripetal force? You all must be knowing centripetal force formula is mv square upon r, or radius. Here the radius they have given us. What is the radius they have given us? A naught. A naught is the radius. A naught is the radius. Mass is m, and E is the charge on the electron. Okay, and E naught is the vacuum permittivity. So we need to calculate the speed of the electron. So it's very easy. Centripetal force is mv square upon r. R is A naught, I wrote. And what is the electrostatic force here? Electrostatic force is equal to K Q1 Q2 upon R ka square. Okay. So again I'll write mv square upon A naught is equal to K. What is the value of Q1 in hydrogen atom? Hydrogen atom, what is the charge? E in proton. And what is the charge in the electron? Again E, because it has one proton and one electron. So E will be the charge in proton, E will be the charge in electron. So it will be K E into E upon A naught ka square. A naught, one A naught gets cancelled. Now I can write it as mv square is equal to K E square upon A naught. Now V square will be equal to K E square upon M A naught. And what is the value of K, guys? What is the value of K? K is equal to 1 upon 4 pi epsilon. 4 pi epsilon. So V square is equal to 1 upon 4 pi epsilon A naught into E square. One more mass. So the value of V will be root over of E square upon 4 pi epsilon A naught M, which will be equal to E upon root over of 4 pi epsilon A naught. This is the velocity of the electron. Okay, so in which of the following the velocity of electron is given by E upon root over of 4 pi epsilon A naught M? In which of the following? Option number C. So option number C is the correct answer, guys. Okay. So with this, I'll move to question number 26. Again, guys, in question number 26, it says, when a hydrogen atom is in its first excited level, its radius is what? Radius is how many times of its ground state radius? As I told you to remember in one of the previous questions, that the radius in Bohr's model of atom is proportional to n square upon z. N square upon z. The value of z here is 1. So I can also write it as r is proportional to n square. R is proportional to n square. So in ground state, n will be equal to what? N will be equal to 1. So R will be proportional to 1 ka square. But in first excited state, n is equal to 2. So R will be proportional to 2 ka square. Okay. So here it is proportional to 1. Here it is proportional to 4. So the radius has become what? 4 times the original. Original means 4 times the ground state value. It has become 4 times. So option number, in which option it is given? Option number A. Option number A says it has become 4 times of its ground state value. Okay guys, I hope it's very clear. With this, I'll move to question number 27. Question number 27 says the spectrum obtained by sodium vapor lamp. See guys, if this is our sodium vapor lamp, this is our sodium vapor lamp. This is sodium vapor lamp. It is an example of which spectrum emitted. It is an example of which spectrum emitted. See guys, again I'm saying this is one of the theoretical chapter in all your in your physics of including class 11th and 12th. So please make sure you read the NCERT for this chapter at least 3 or 4 times. Okay, because you might get a theoretical question like this in your exam. Okay, and if you don't have any idea of this, you will not be able to attempt. This is not any numerical that you can make your brain work and solve the question. This is theoretical question. Either the answer you know or you don't know. There is nothing in between. So please make sure you go through the NCERT lines before going for the main exam. Yeah. So this question says the spectrum obtained from a sodium vapor lamp is an example of what? The sodium vapor lamp, always remember, this always give rise to emission spectrum. This give rise to emission spectrum. Sodium vapor lamp. It is an example of emission spectrum. So option number C. Okay, spectrum obtained from a sodium vapor lamp is emission spectrum. A spectrum is observed when the light coming directly from a source is examined with a spectroscope. Okay, it can also be asked how it is examined. It is examined with the help of a spectroscope. You can remember this. Okay, so with this, I'll move to question number 28. Question number 28 says, when a hydrogen atom is raised from ground state to an excited state, its potential energy, what will happen to its potential energy and what will happen to its kinetic energy? So, if you all know, if this is a hydrogen atom, guys, for an hydrogen atom, the potential energy is given by what formula and the kinetic energy is given by what formula? The potential energy is given by K into E square upon A naught, A naught of or R, okay, and minus. And the kinetic energy is given by plus K E square upon 2 A naught, 2 A naught. Okay, kinetic energy is half of potential energy. Okay, if you know, this is the hydrogen atom's formula. Yeah, so this, when it was in ground state, when it was in ground state, this is just formula. Okay, how did I calculate potential energy? Means potential energy, you know the formula, guys. K Q1 Q2 upon R. Okay, so Q1 Q2 is E and E because value of charge in proton is E, value of charge in electron is E, and the radius A naught. So the potential energy value is this, and this is the kinetic energy value. So in an excited state, in an excited state, value of potential energy will be, what will happen in an excited state? Radius will increase. Radius will increase. Okay, and if the radius is increasing, what will happen with the potential energy? Potential energy will be even more negative. More negative. It will be if the radius is increasing, what will be its formula? K E square. I'll write it properly. A. And the value of A is more than A naught. Value of A is more than A naught. So what will happen here? The whole value will decrease. Whole value will decrease, but then see, if it was -5 here, what will be the value here? It will be -2.5 or something like that, because the denominator value is increasing. Denominator value is increasing, so the total value should decrease. Okay, but it is decreasing in negative, so the potential energy will increase. Okay, and what is happening with kinetic energy? Kinetic energy, since it is in positive and the radius is increasing, K E square upon 2A, and the value of A is again more than A naught. Okay, so the value will decrease. Okay, in which of the following option it is given potential energy is increasing and kinetic energy is decreasing? Option number B. Option number B. Okay, so with this I'll move to question number 29. I hope the question number 28 was very clear for you. With this, question number 29. Question number 29 says, who indirectly determined the mass of the electron by measuring the charge of the electron? By measuring charge. Who detected the mass of electron? Who detected the mass of electron? Who it was? It was Thomson. Again, theoretical question, guys. If you know J.J. Thomson's experiment, you can easily answer this question. Okay, guys. So with this, I'll move to next question. Question number 30. Answer is option number D, J.J. Thomson. Question number 30 says, the radius of hydrogen atom in its ground state. The radius of hydrogen atom in its ground state. Ground state mane n is equal to 0, and for hydrogen atom z is equal to 1. Sorry, ground state mane n equal to 1. Okay, it is equal to 5.3 into 10 to the power minus 11. Okay, and after collision with an electron, it is found to have a radius. Z equal to again 1. Found to have a radius of 21 upon 2.2 into 10 to the power minus 11. This also 11. 10 to the power minus 11 meter. Okay. Asking what is the principal quantum number of n in the final state? What is the value of n in the final state? They are asking. At to what excited level it went after the collision of electron? After the collision with electron. So, as you guys know, radius is directly proportional to n square upon z. But since the z value is 1 here, you can also write a radius is directly proportional to n square. Yeah? Till this you understand? So now the value of radius in its ground state, r equal to 1 was equal to 5.3 into 10 to the power minus 11. Okay, and it is proportional to n square. N square means 1 square. It is proportional to 1 square, you can write, because it was in ground state. But when the it went to an excited state N, Rn is equal to 21.2 into 10 to the power minus 11. It is also proportional to n square. It is proportional to n square. It is proportional to 1 square. Okay. So now if I divide the equation number 1 with the equation number 2, what will you get? R by R1 upon Rn is equal to 5.3 into 10 to the power minus 11 upon 21.2 into 10 to the power minus 11 is equal to 1 ka square upon n square. Yeah? So 10 to the power minus 11, 10 to the power minus 11 cancel. 5.3 upon 1.21.2 will give you 1 upon 16 is equal to 1 square upon n ka square. So the value of n square here you get is 16. Value of n square is 16. So what is the value of n? What will be the value of n here? Value of n here will be root over of 16, which gives you n equal to 4. Did you understand, guys, how I did this question? See, you always remember that radius is directly proportional to n square upon z. Then the question is done for you. You remember n square r is proportional to n square? Then you have the values for radius in the first state and the radius in the excited state. Then you can easily calculate. I just had to divide the equation number 1 with the equation number 2. Then I had my answer. N is equal to 4. Option number A. Sorry guys, this is just a calculation error. 5.3, 21.2 upon 5.3 will give me the value of 4. So n square is equal to 4. N will be equal to root over of 4, which will be equal to n equal to 2. N equal to 2 is in option number B. Okay. So with this, I'm moving to question number 31. Again, a theoretical question. Which source is associated with line emission spectrum? Line emission spectrum. Which one of the following is associated with line emission spectrum? Is it electric fire? Is it neon street sign? Is it red traffic light? Or is it the sun? You always remember the line emission spectrum is emitted by option number B, neon street sign. Okay, guys. So again, I'm telling you, please go through the theory so that you can answer these questions. Okay, guys. So two more questions for today's session. Question number 32. Question number 32 says, in terms of Bode's radius, what is Bode's radius? Bode's radius is A naught, which is proportional to n square upon z. Again and again, I'm telling you. So you remember. So what will be the radius of the second Bohr orbit of hydrogen? This was in the ground state. What will be in second orbit? What will be the radius in the second orbit of hydrogen atom? Second orbit of hydrogen atom. Second orbit means n is equal to 2. What will be the orbit, or what will be the radius? If the radius is a, it will be proportional to n ka square. Here n was 1, so it is proportional to 1. Here n will be n ka square upon z. Z is again 1. The value of Z is 1. So A is proportional to 4. So if the ratio, if the radius was A naught when n equal to 1, so what will be the value of radius when the value of n is 4? Value will be 4 A naught. Okay, so the answer here is option number A. Okay, so guys, a few more important things related to the chapter atom I would like to tell you here, because in this PYQs some of those important things were missed, I felt. So starting with this, I will write all the important things which you need to remember before you go to your exam. Okay, starting with this, the radius is very important. Please make a note of this. Radius is proportional to n square upon z. Okay, velocity of electron. I did not see even a single question to this, but maybe a future question. Velocity is proportional to z upon n. Please remember this. Make a note of this. And then time period. Time period of an electron is proportional to n cube upon z square. N cube upon z square. Okay, and related to this formulas, and please guys, whatever formulas you are getting while solving questions, please make a note of this, and it will be helpful for you at the end to revise. Yeah, so make a formula copy for each and every chapter. Okay guys, so this was for A naught. Option number A was the answer. I hope you understood that. With this, I'll move to question number 33, or today's last question. Question number 33 says the ionization energy of hydrogen atom is 13.6 electron volt. Again guys, what is the energy of hydrogen in an orbit? What is the energy in an hydrogen orbit? My hydrogen atom minus 13.6 Z square upon n square electron volt. Okay, so following a Bohr's theory, the energy corresponding to the transition between third orbit and fourth orbit. How will you calculate? How will you calculate this, guys? If these are the four orbits, when n is equal to 1, the energy will be minus 13.6 into 1 ka square. Z square means 1 square, so I'm not writing that anymore. Then again 1 square. So it will be minus 13.6 electron volt. And then when n is equal to 2, it will be minus 13.6 upon 2 ka square, that is 4. Then at the 3, it will be minus 13.6 into 3 ka square, which is 9. Then at the fourth orbit, it will be minus 13.6 upon 16. Okay, so if you solve this, you'll get what values I'll write here. First orbit's energy is minus 13.6. Second orbit's value is minus 3.4. If you can remember these values also, it will be very helpful for you. You will not have to calculate this again and again when you need to solve any question. Yeah. So second orbit will be minus 3.4 electron volt. Third orbit will be minus 1.51 electron volt. In the fourth orbit, it will be, when you divide minus 13.6 upon 16, you'll get the value of minus 8.5 electron volt. Minus 0.85 electron volt. Okay, so now I coming back to the question. In question they are asking you the ionization energy they have given you minus 13.6 electron volt. Why the ionization of energy of hydrogen atom is 13.6? Because the electron always lies in the first orbit, and when you give an energy of 13.6, it has energy of minus 13.6 electron volt. So when you give an energy of plus 13.6 electron volt, it will come out. The energy will come out and the hydrogen will be ionized. Do you understand this, guys? That is why the ionization energy is 13.6 electron volt. So now coming back to the question, following the Bohr's theory, the energy corresponding to the transition between third and fourth orbit. This is the third orbit. This is the fourth orbit. What will be the transition? Transition means to calculate the transition, what you have to do? The energy difference between the fourth orbit and the third orbit. Indirectly, they are asking you what is the energy difference between the fourth orbit and the third orbit. What was the energy in the fourth orbit, guys? It is minus 0.85 electron volt. What is the energy in the third orbit, guys? Minus 1.51 electron volt. So if you subtract 1.51 minus 0.85, you will get the value of plus 0.66 electron volt. Option number D. Did you understand what I did in this question, guys? The ionization energy of an hydrogen atom was given 13.6. What do you mean by ionization energy? The energy you need to give to an atom to remove its electron, to make the atom ionized. So the first orbit's energy is minus 13.6. They are saying you indirectly. And then I calculated the energy of the second, third, and fourth orbit by using this formula. En is equal to minus 13.6 z square upon n square. I calculated second, third, and fourth orbit's energy. Then they asked me what is the energy corresponding to the transition between third to fourth orbit. So to calculate the transition between third to fourth, you have to calculate what? The energy difference between the fourth and the third orbit. Yeah. So I needed to just subtract E4 minus E3, and I got plus 0.66 electron volt. So guys, with this, I am finishing the chapter atoms, all the previous year questions. I really hope you enjoyed the section, and I made some of your concepts very clear. And again, I will remind you of this. Please remember all this. Radius is proportional to what? Velocity is proportional to what? Time period is proportional to what? I forgot to mention energy. Energy is proportional to z square upon n square. So please, guys, this should be in your fingertip before the exam. Okay. So with this, I'm finishing today's session. Please, guys, study well. All the best.